Hey, what do you say, math leaguers? This is your week 3 midweek hints. Picked out a few problems for you just to give you some hints on. Once again, a lot of you guys, if you're maybe in like 8th grade, you've probably seen a lot of this before, but maybe if you're in some of the younger grades, you may not know a lot of this stuff. So, anyway, which ones did I pick out? I picked out number 3 for you to look at. On number 3, it's got different angles, but it says that there's a pair of parallel lines, and then another line that crosses it, and it's asking for like the value of x. They have different equations and different variables and things like that, but this is the basic premise here. Hopefully you guys know this, but if you don't know this, anytime one line crosses another line, 2 angles are formed, there and there. Now, if this is completely vertical or perpendicular, whatever you want to call it, oh, that's a terrible right angle, but then we would add the 2 right angles together, and this large area here would be a 180 degree angle. 90 degrees plus 90 degrees would be 180 degrees. Anytime you add the 2 angles that are created by 2 lines, you get 180 degrees. Now, for example, if I were to tilt this in, that would become less than 90. Let's make up a number. Let's say 70. Well, what happened to this one? By the same amount that this is less than 90, this is now more than 90. So this would be 110. So once again, when you cross a line with another line, you create 2 angles whose sum is 180. So all you really have to do here, like to figure out some of these angles, for example, if this is 100 degrees, this angle right here has to be 80 degrees. Never mind the drawing, it certainly doesn't look like it's 80, it looks like it's less than that. But you get the idea, okay? All right, now, what about this up here? We don't have a match for this 2x, we don't know any of these angles, but it says these 2 are parallel. So when this line crosses it, it's crossing it at the same angle, which means that the corresponding angles are equal, right? This is crossing here the same way that it's crossing here, so this is going to be 80, all right? And what's this going to be? 100. And what's this going to be? Because it's crossing this line. This is going to be 80, so 2x would be 80, so x would be 40. Okay, when you get into like high school geometry, there's a lot of this stuff. It's actually pretty easy. And a lot of you guys probably already know that, but it's important that you guys know that. All right, so parallel lines crossed by another, you create corresponding angles, and you can just, make them add up to 180 and then solve for x. All right. Number 5, I think I wrote myself a note that I'm going to be doing number 6 and 8. Number 5 said, I know what the note was. Number 5 says, the diagonals of a rhombus are always perpendicular bisectors. Kind of a fun fact, okay? Knowing this, what would be the perimeter of a rhombus whose diagonals were the length of 12 and 16 units? So all I'm doing for you here is just making up like the exact same problem, but instead of 12 and 6, oh boy, that's all right. 12 and 16, I chose 6 and 8, okay? Now think about this. I said if this long one is 8, and if this is a bisector, then what's that? 4. And what's that? 4. Okay? Now, if this is 6, because that's what the problem says, let's say, and if this is bisected, then that's 3. There's my dog coming in. And that's 3. Okay. So now what we have here, they are perpendicular bisectors, which means these are all right angles, which means these are just right triangles, which means this is a 3, 4, 5. We should know by 3 squared plus 4 squared is 5 squared. Should know your Pythagorean triples. This is 5. This is 5. This is 5, and it's asking for what's the perimeter, okay? So the perimeter would be 20. Okay, now obviously I gave you different numbers for your problem, but that would be that. Okay. I'm also, just randomly, it just so happens, I am doing number 6 and number 8. I'm going to save some room for number 6, so I'm going to do number 8 first. Number 8 is the one, there's a picture, and it's how many rectangles can you create from this like grid here. Mine is bigger on the real problem. I made a smaller one. I like to do that in the hint to make a smaller example. You can apply the same tools and techniques to the smaller example. I think the easiest way to go about it is to like break it into literally a separate grid. Like this is a 2 by 1 grid, okay? Now you could obviously just count the number of rectangles. Forget about the red one. You could just count 1, 2, and then 3, right? And we're not working on the red one yet. So this blue grid here would have 3 different rectangles that you can make. There was the formula, if it's A times, like an A by B grid, the formula is A plus 1 combinations of 2 times B plus 1 combinations of 2. So that's 2 by 1, so that's 3 combinations of 2 times 2 combinations of 2. 3 combinations of 2 is 3 times 2 divided by the ways you can rearrange them, which is 2 times 1 or just 2. So that's 3. And then 2 times 1 divided by 2, which is 1. So it's 3. Just the blue one, which we already counted and I proved to you. So I think the easiest way to do the problem is to do the blue one and then just say, all right, how many more rectangles can you make that involve the red rectangle, right? So all the ones that are just here without the red rectangle, now how many can you make with the red rectangle? Well, you can make 1, that's the red rectangle itself, and you can make a second one, which is like a 1 by 2 rectangle, and that's it, so 2 more. So the grand total for this thing would be 5. That's how I would do my problem, is I would do the regular grid and then figure out how many extras you could make with that loose rectangle that's on the problem. Okay. Oh, and by the way, the answer was, if anybody did this really, really early in the week, like right away on Monday, the answer was off by 1. It's fixed. If you had any problem with that, like, and you want to send me an email and say, Mr. T, I swear I had this answer originally, and so I didn't get the full credit, just send me an email and we'll find a way to get you an extra bonus point or half a bonus point or whatever you need to make up for that. I know one person who like did it on the first day, and so when the problem was a little bit off. All right, finally I'm going to do number 6. I don't know if you guys know how to do this. There's some big time algebra going on here, and geometry. But number 6 is like, what's the number of units in the area of a shape bounded by a bunch of lines. All right, so this is number 6. Here's a Cartesian coordinate graph. All right, I'm just gonna say, make a random line y equals 1/3 x plus 2. Okay? Now again, we learned this last week. This is y equals mx plus b, slope x plus y-intercept. Y-intercept is 2. Slope is positive 1/3 or up 1 over 3. So like so. Whee! And it just goes on and on forever like that. And on forever like that. Okay? Then let's make another line. Y equals negative 1/3 x plus 2. So y-intercept is 2. But this time we go down 1 over 3. Or we could go up 1 and left 3. And we go whee! Like so. Okay? So right now nothing is bounded, right? But then we're going to get a third line. And the third line is going to be y equals 1. Y equals 1. I'm going to use a different color here. Well, let's use the red one. Okay. That's a tricky one. You could do slope intercept. You could say y equals 0x plus 1. So the y-intercept is 1. The slope is rise 0. Don't go up. Run, you could put any number underneath that. Rise 0, run 1, or rise 0, run 2, or 3, or 4. Whee! Like so on. Okay? Now, not very well drawn, but that would be the way it is. You also don't need to put it in y equals mx plus b. You can just say y is always 1. My height is always 1. Okay. Now, what is bounded by these lines? It's this triangle right here is the shape that is bounded by those lines. Okay? So, how do you find the area of a triangle? Base times height. Well, it's pretty obvious that the height is just 1. Right? And the base is, if you think about it, here we went like down 1 over 3 and we got to there. So this distance here is 3. This distance here is 3. So the base is 6. So the area, so that the base is 6, the height is 1. So it's 6 times 1. Ooh, terrible. 6 times 1. But what do you do when it's a triangle? Remember, the area of a triangle you have to divide by 2. So the area of that triangle is 3. Now, the shape that I gave you on the real problems is a little more complicated. All right? It doesn't come out to a triangle. What does it come out to? I think it comes out to a pentagon. All right? So you got some mixing and matching. And, by the way, if you ever want to, solve the area of a pentagon, especially if it's in the shape of a house, you can just do the area of the triangle plus the area of the rectangle. Just saying. All right. I'll save the joke for, I've heard a really good joke. Do you guys know this guy? Sorry, I'm getting off track. If you ever get a chance and you're on social media or whatever, probably a lot of you guys already saw this guy. He's a great math dude. He just gets and makes cool videos about math. And he had a great joke the other day. I'll tell it at the end of the week. Okay, his name is Howie Hua. All right, look him up, Google him or whatever, and you can watch some of his videos. He does cool math tricks and stuff like that. Kind of like we do. Hopefully, you think that. All right, have a good day.